Hello everybody, it's Wednesday the 24th of February and this is your maths lesson for today. We're looking at subtracting fractions still, but we're looking at subtracting mixed numbers, so that's whole numbers and fractions together. For this you're just going to need paper and pencils. You might want to draw some number lines or some fraction bars to help you, and we'll get started. Coming up is your 4 a day, so pause the video and have a go at that. Here are your answers to your 4 a day. If you can pause the video, have a look and see how you did and work out any mistakes that you made and how you can correct them. So let's get ready with our first brain teasing questions. Just to get our brains going, pause the video and have a go at these questions. Let's have a look and see. Number 1, it says convert these mixed numbers to improper fractions. So the first one is 5 whole and 3 fifths. Now if our denominator for our fraction is fifths, that means our whole numbers, what would they be in fifths as well? So to do that, it would be 5 times 5 fifths. So 5 fifths is 1 whole. We've got 5 of them. 5 times 5 fifths is 25 fifths. So 5 wholes is 25 fifths plus the 3 fifths. That would give us a total of 28 fifths. And the same we could do for our 3 wholes and 8 ninths. We could do 3 times 9 ninths, which is 27 ninths, because 9 ninths is our whole. Then 27 ninths plus 8 ninths gives us a total of 35 ninths. And then for part 2, it said convert these improper fractions to mixed numbers. And we have 102 tenths. Well, we hopefully know that 10 tenths is 1 whole. So 100 tenths would be 10 wholes. And then that would leave us with the 2 tenths left over. So 102 tenths is the same as 10 wholes and 2 tenths. And then for 124 twelfths, wow. Well, I know that 10 times 12 is 120. So 120 twelfths are 10 whole numbers. And then my 4 twelfths left over would have given me 10 wholes and 4 twelfths, or 10 wholes and a third. Well done if you managed those. We're going to get going with our main lesson now. So I'm going to be asking you some questions, working on some things together, and leaving you to have a go by yourself. So let's begin with this question here. We have 7 fifths subtract 3 tenths. And our 7 fifths is our improper fraction. It's an improper fraction because the numerator is larger than the denominator. And here are our 7 fifths. So each section is worth 1 fifth. Here we have 5 fifths together, which is 1 whole. And then we have our 2 extra fifths for our 7 fifths. And we're going to take away, though, 3 tenths. We can see our denominator is not the same. So what could we do to this fraction bar to help us? I'll give you 5 seconds to have a think. We could, with our fraction bar, split it. So now we have our tenths. So now we've got 10 tenths here, and we have got 4 tenths here. So we've got, actually, by timesing by 2, we've got 14 tenths. Now we can do 14 tenths subtract 3 tenths. And we can take those 3 tenths away, and that leaves us with 11 tenths. And what would that be as our mixed number? Using our fraction bar to help us, 1 whole and 1 tenth. So using that skill, we could try it on a number line. So there are 2 ways that we could try it today. We've got our 7 fifths take away 3 tenths. Each of our fraction parts here on the number line are worth 1 fifth, 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths, or 1 whole. So where would 7 fifths be? Here we have our 5/5, so our 2 holes must be 10/5. So 7/5 would fit there on that marker on that number line. We can then turn our number line from fifths into tenths, and we can convert our fraction. So now we've got 10 tenths is 1 whole, 20 tenths is 2 wholes, and we've converted 7/5 again by timesing by 2 to 14 tenths. There's our 3 tenths, and we know that it's 7 tenths to the next whole, then 4 more tenths, and that's our 11 tenths again, or our 1 whole and 1 tenth. So there are 2 ways that you could work it out, using fraction bars or using a number line. You can, if you want to, use your times table skills as another way of using it. But if you want to draw pictures, you would have to choose now. What do you feel happier doing? Do you prefer doing fraction bars, or do you prefer using the number line? You would need to make that decision, so later on you can use that as a way to help you calculate. So we'll try the number line. Have a think. What would 2 whole and 2/3 take away 7/9 be? Pause the video and have a go. Which of these would you have to change so you have the same denominator? Where would they go on the number line to help you work them out? 2 wholes, what would that be as thirds? Have a go trying to work it out. Let's have a look and see. There is 2 wholes and 2/3 on our number line, and we could change them into ninths. So 2 wholes and 2/3 would become 2 wholes and 6/9. 7/9 would be here on the number line, and then we would find the difference. To get us to the next whole number, it would be 2/9. Then we're jumping 1 whole number. Then we're jumping 6 more ninths to 2 wholes and 6/9. And then we can add 2/9, add 6/9, add 1 whole, which equals 1 whole and 8/9. Now you might have done it slightly differently. You might have used a fraction bar or used your times tables to help you, as long as you got that right answer. It's your turn now. Some questions are coming for you to have a go at. Have a go at them and see what you can do. To begin with, it's completing the subtractions. Use the bar models to help you. So you've got 15/8 take away a half. What would you need to do first? Because your denominators are not the same, so what's the first thing you would need to do? And can you use your fraction bars if you need to help you? Have a go at those 3 questions, and then your answers will come after. Let's have a look. For the first one, it was 15/8 take away a half, and we could have converted our half by timesing by 4 to 4/8. 15/8 take away 4/8 is 11/8, and 11/8 is an improper fraction into a mixed number, would be 1 whole and 3/8. For question B, we could have converted by timesing by 2 our 3/4 into 6/8. Then we would have just done 1 whole and 7/8 take away 6/8. We wouldn't need to worry about our 1 whole, that would have stayed the same. And so our answer will be 1 whole and 1/8. And for our last question, 1 1/2 take away 3/8. We would have converted our 1 1/2 into 1 whole and 4/8. 1 whole we could have ignored. 4/8 take away 3/8 is 1 whole and 1/8. Well done if you managed to do those. This time having a look at these ones. We've got 6 to try. Pausing the video, completing the subtractions, and again it's looking at denominators are not the same. So what would you change? Remember, if you have a mixed number, you could convert it to an improper fraction if you wanted to, or if you wanted to, ignore the mixed number and focus on your converting and then putting them back on. Pause the video and have a go. Here are your answers. For 3 holes and a quarter, you would have needed to have changed them to 24ths. So timesing by 6 would have changed it to 3 holes and 6 24ths, taken away. For question B, we would have converted our 8ths to 16ths by timesing by 2. So it would have been 3 holes and 3 16ths, take away 2 16ths. For C, we could have converted again by multiplying by 2, 2/3 to 4/6. And 2 and 5/6, take away 4/6 is 2 holes and 1/6. For our question D, we'd have had to have changed the 5/6 in our 7 holes and 5/6 to 20 24ths and calculated it that way. The same again, changed our 4/9ths by timesing by 3 to our 4 holes and 12 27ths. And then for the last question, we would have changed our 3/4 by timesing by 3 to 9/12ths, giving us the answer. You could have had 6 holes and 3/12ths or 6 holes and 1/6. Well done if you managed to do those ones. Let's have a look at this problem together. A race is 3 2/3 of a kilometre in length. So that's 3 kilometres and 2/3 of a kilometre in length. Annie runs 1/6 of a kilometre so far. How much further does she have to run? So pause the video and have a think. What do you think you would do to answer this question? Would you draw a fraction bar, a number line? What would you need to convert? Because do you have fractions that don't have the same denominator? Pause the video and have a think. How would you find the answer to this one? Let's have a look and see. Well, here we have our 3 whole kilometres and 2/3 of a kilometre, and we have to take away 1/6. So we have our denominators are not the same. So if we were to do fraction bars, we could split them into our sixths. So now we have 3 wholes and 4/6. And if we were to do that, we could take away our 1/6, and that would leave us with 3 wholes and 3/6. And 3/6 is the same as a half, 3.5 kilometers to run. So having a go, what would you do about this problem here? We've got 5 wholes and our numerators are missing. We have a denominator of 30 and a denominator of 6, but our answer must be 5 wholes and 7/30ths. So the first thing we would need to do is multiply by 5 to change our 6 into 30ths. Now we've got to come up with 5 wholes and something 30ths, take away something 30ths as well. What could go there? We could have 14 30ths, take away 7 30ths. That could be a possibility. But would that work? Can we change that? We can't change our 7 30ths is not the same as 1/6, so that wouldn't work. We know 1/6 is 5 30ths. So if we know that 1/6 is 5 30ths, what could we have here that would give us our answer of 7 30ths? Have a little think. Let's have a look and see. If we have added 7 30ths to our 5 30ths, we'd have got 12, and there would be our difference. So using that method to help you, how could you answer this question? Is there another way you can think of coming up with a different answer? Well, if we'd have changed it to 2/6, we could have had 17 30ths. That was one way we could have done it. Let's have a look at this question here. Alex cycles for 8 kilometers. Mo cycles for 7 whole kilometers and 5/8 of a kilometer. How much further does Alex cycle than Mo? And using the number line if you want to help you, how would you work that out? Pause the video and have a go. Let's have a look and see. Well, Alex cycles 8 kilometers. Mo cycles 7 whole kilometers and 5/8. We can see our number line has been split into 8 parts. Here is our 5/8. So what is the difference between Mo and Alex's distance? We can see that it is 3/8. How much further has Alex cycled than Mo? 3/8 of a kilometer. Well done if you managed to do that one. Let's have a look at this problem. Jack eats 1 whole and 2/5 of a pie. Dora eats 9/10 of a pie less than Jack. How much pie does Dora eat? Here we can see our number line, and you have our tenths. So we could have converted 2/5, 1 whole and 2/5 to 1 whole and 4/10. Here we have 1 whole and 4/10 on our number line. And we would have jumped back 9/10. And where would that have landed? What would the counting back 9/10 have landed you on? We can see it would have been 5/10. What's 5/10 the same as? It's the same as a half. Well done on that one. Now we've got some more questions for you to try. So pause the video, have a go at those questions, and then your answers will follow. Let's have a look at this question. A jug contains 1 whole and 3/5 litres of orange juice. Eva pours 4/15 of litres into a glass. How much orange juice is left in the jug? Pause the video and have a go. Look at the information you have been given. What would you need to do? Look at the language involved. How much orange juice is left? So if you've got that, what calculation do you need to do? You also don't have any, the two denominators are not the same. So what would you do? Pause the video and have a go. So let's have a look and see what should we have done. Well, we could have seen that our denominators were not the same, and if you multiplied by 3, we could have changed our 1 and 3/5 to 1 whole and 9/15. Then we could have done 1 whole and 9/15 subtract 4/15, which would have been 1 whole and 5/15, which is equivalent to 1 whole and 1/3. Next question, it says find 3 different ways to complete the calculation. Are there any other ways to complete this? So you've got 3 wholes and something fifths, take away something 20s, and your answer must be 3 wholes and 1/20 each time. This is like the one we tried before, so if you're unsure you can pause the video and go back to see how it was done before. Coming up are 3 possible answers. You might have some others that you might have found as well. Pause the video and have a go. Here are some of the examples that you could have had. You might have found some other ones as well. So we've got 1/5, take away 3/20, so you would have had to have done some converting there. Well done if you managed to find any of those answers. This next problem, there are different parts to do. It says 3 children took part in throwing competitions. Here is a table of results. You can see they did the javelin, the shot put and the discus. And Dexter, Amir and Annie each took part, but we've got some missing information. Use the clues to complete the table. Annie's javelin throw is 11/12 of a metre less than Dexter's. Well, Dexter's javelin throw was 15¼ metres. So what will you have to do to find out how to find 11/12 less than this fraction? Amir's shot put throw is 3/4 of a metre less than Annie's. So if Annie threw 9 metres, Amir threw his shot put 3/4 of a metre less, what would have gone there? And then Dexter's discus throw is 1/2 metre less than Amir's. Again, what would you do to find that out? Pause the video and have a real good go at these. Here are your answers. How did you do? It was quite a tricky one, but well done if you managed to have a go at those. And again, here's our little extra challenge of an odd one out. Can you work out what would be the odd one out? So we have 3/5 add 9/20, 15/8 take away 7/4, 23/15 take away 1/3. Can you calculate those and work out your answers? And then, but what would be the odd one out? That's a real challenge. Can you identify, like yesterday, your own ideas of what the odd one out could be? Could be a variety of reasons. Can you think of your reasons? Maybe because some of your answers are larger than one whole or less than one whole. It may be you have the same denominators. What could be the odd one out? Have a go. And that's the end of our lesson for today. And again, if you want to continue practicing, you can go to MathsFrame and try these different activities for you to practice your skills. But very well done. And again, I will speak to you not tomorrow because it will be your Mathletics day. But I'll talk to you on Friday and I'll see you then. Bye bye.